In the final months of the Second World War, Germany was running out of almost everything that had once made its military machine possible. Ammunition was becoming scarce. Spare parts were difficult to find. Aircraft were grounded for lack of fuel. Trucks sat abandoned beside roads because there was nothing left to put into their tanks. Armored units that had once moved across Europe with astonishing speed were increasingly forced to remain where they stood. Yet beneath forests, hillsides, industrial complexes, and seemingly ordinary patches of countryside, a hidden network of bunkers still contained one of the most valuable resources left to the collapsing German war machine: fuel. These underground storage sites were not simply warehouses. They were carefully engineered systems designed to protect petroleum products from bombing, sabotage, fire, and enemy observation. Some were built beneath concrete structures. Others disappeared into wooded terrain, concealed behind camouflage, earthworks, railway sidings, or industrial facilities. Their tanks, pipes, pumps, ventilation shafts, access tunnels, and security systems formed a hidden infrastructure that connected the German military to the fuel it desperately needed. By 1944 and 1945, however, the strategic situation had changed dramatically. Earlier in the war, German forces had depended upon enormous quantities of petroleum to sustain operations across Europe and beyond. Tanks needed gasoline. Trucks needed gasoline. Aircraft required aviation fuel. Naval vessels required fuel oil and diesel. Even ordinary military life depended upon petroleum: generators, heating systems, construction equipment, transport vehicles, and countless machines all consumed some form of fuel. The German leadership understood the importance of petroleum from the beginning. The country possessed limited domestic crude oil resources compared with the demands of a modern industrial war. This problem had influenced German strategy long before the invasion of Poland. Synthetic fuel production became particularly important, with chemical processes transforming coal into liquid fuels. Refineries and synthetic fuel plants therefore became strategic targets for the Allies. As Allied bombing intensified, the question was no longer simply how to produce fuel. It was how to protect what remained after production. This was where hidden storage facilities became crucial. A fuel bunker could be extraordinarily valuable even when its contents were relatively modest. A few tanks of aviation gasoline could keep a fighter unit operating. A reserve of diesel could move trucks carrying ammunition or evacuate wounded soldiers. A cache of gasoline could give an armored formation the ability to relocate at a critical moment. In a war increasingly determined by mobility, fuel was not merely a commodity. It was movement itself. The importance of these hidden reserves became even clearer during the German retreat from the Eastern Front and the final defense of Germany. The army was losing territory, transportation networks were collapsing, railways were being destroyed, and Allied aircraft dominated much of the sky. Fuel deliveries that had once moved according to carefully planned schedules were increasingly interrupted. The bunkers therefore became the last link in a supply chain that was itself beginning to disappear. Imagine approaching one of these sites during the final months of the war. From the outside, there might be surprisingly little to see. A wooded hill could conceal concrete entrances. A factory might contain rooms that appeared to be ordinary utility spaces. A railway line might terminate near structures whose real purpose was invisible from the air. Pipes could disappear beneath the ground and emerge hundreds of meters away. Ventilation shafts might be disguised among trees or industrial equipment. The entire principle was concealment. The Allies knew that German petroleum infrastructure was a critical target, and aerial reconnaissance was constantly improving. A large above-ground fuel depot was vulnerable because its tanks could be identified from the air. A successful bombing attack could ignite fuel, destroy pumps, rupture pipelines, and eliminate the ability to distribute petroleum. Underground storage offered protection. But underground construction was expensive, complicated, and time-consuming. Engineers had to consider groundwater, ventilation, structural pressure, drainage, access, fire prevention, and the movement of fuel through the facility. Storage tanks needed to be positioned so that fuel could be received and later dispatched efficiently. Pumps required power. Workers needed safe access. The entire system had to function even under wartime conditions. And the fuel itself was dangerous. Gasoline vapor could ignite explosively. Aviation gasoline required careful handling. Diesel and fuel oils presented different risks, but large quantities still posed enormous fire hazards. A bunker could protect its contents from bombs while simultaneously creating a confined environment where an accident might become catastrophic. For this reason, fuel storage facilities often incorporated extensive safety systems. Ventilation was essential because vapors could accumulate. Electrical equipment had to be controlled carefully. Drainage systems were necessary to prevent spilled fuel from spreading. Fire suppression and emergency procedures were important. Personnel working inside needed to understand that one spark could turn a storage facility into a death trap. The German military and industrial organizations responsible for fuel infrastructure developed increasingly sophisticated methods for dealing with these problems. Yet no engineering system could solve Germany's fundamental strategic problem. There simply was not enough fuel. The crisis became especially severe in 1944. Allied attacks against German oil production intensified. Synthetic fuel plants and refineries were bombed repeatedly. Railway networks were attacked. Tanker transportation became increasingly difficult. Fuel production fell, and reserves were consumed faster than they could be replaced. The consequences appeared everywhere. German pilots trained less because aviation fuel was scarce. Experienced pilots could not always fly enough missions to maintain readiness. Tanks were sometimes immobilized. Vehicles were abandoned. Military formations that possessed large numbers of weapons could find themselves incapable of moving those weapons. This is one of the most important lessons of industrial warfare: having machines is not the same as being able to use them. A tank without fuel is an armored bunker. A truck without fuel is a stationary cargo container. An aircraft without fuel is a machine sitting on a runway. Germany's remaining underground fuel reserves therefore acquired an importance far beyond their physical size. Some storage facilities were connected to rail systems because petroleum could arrive in tank cars. Others were supplied through pipelines. At the depot, pumps transferred fuel into storage tanks. From there, another network could move it toward military units, airfields, factories, or transportation hubs. The underground depot was therefore one component in a much larger machine. To understand how these bunkers mattered, it is useful to imagine the journey of a single liter of gasoline. It might begin as coal converted into synthetic fuel at an industrial plant. From there, it could travel by rail toward a regional storage facility. The tank car might arrive under guard, perhaps during darkness to reduce the danger from Allied aircraft. Workers would connect hoses and transfer the fuel into storage. The underground tanks would hold it until transportation became available. Then, perhaps weeks later, military trucks would arrive. The gasoline would be pumped from the storage tanks into transport containers or tanker trucks. Those vehicles would leave the depot and travel toward an airfield, army formation, repair center, or distribution point. Every stage represented a vulnerability. The plant could be bombed. The railway could be destroyed. The depot could be discovered. The trucks could be attacked. The airfield could be bombed. The entire chain could fail because of a single missing link. This explains why Germany constructed multiple layers of storage and distribution. A central depot could be supported by smaller regional facilities. Smaller facilities could feed forward units. Underground storage made it harder for Allied aircraft to destroy everything at once. But by 1945, the Germans were increasingly forced into a defensive strategy. Fuel was no longer being accumulated for enormous offensives across Europe. Instead, remaining supplies were being reserved for immediate military necessities. This changed the character of fuel storage. Earlier in the war, fuel was part of preparation for movement. Now it was part of survival. The difference was enormous. A hidden bunker might contain fuel intended for a counterattack, but if the army had no ammunition, insufficient personnel, and enemy forces approaching from multiple directions, the fuel could not restore Germany's strategic position. It could only delay collapse. There was another problem: access. A hidden fuel reserve was useful only if it could be reached. As Allied and Soviet forces advanced, transportation routes became increasingly fragmented. Rail lines were cut. Bridges were destroyed. Roads were damaged. Communications broke down. Orders became contradictory or arrived too late. Fuel depots could remain physically intact while becoming strategically irrelevant. This happened repeatedly during the final phase of the war. A bunker could still contain thousands of liters of fuel, but if the roads leading to it were controlled by the enemy, the fuel was effectively lost. In some cases, German personnel deliberately destroyed fuel stocks rather than allow them to fall into enemy hands. This was part of the broader policy of denying resources to advancing Allied forces. Fuel could be drained, burned, or otherwise rendered unusable. The result was a strange contradiction. Some of the last German fuel reserves were among the most valuable resources in Europe, yet their owners sometimes had to destroy them. The destruction of fuel was not unique to Germany. Retreating armies throughout history have often destroyed supplies they cannot carry. But petroleum was particularly dramatic because of the danger involved. Burning a large fuel depot could produce enormous flames, thick smoke, and intense heat. A bunker could survive an air raid only to be deliberately destroyed from within. The physical remains of these sites can be deceptive today. Many underground installations have been sealed. Some were demolished after the war. Others were repurposed. Some disappeared beneath vegetation or new construction. Concrete structures that once represented highly sensitive military infrastructure may now look like abandoned industrial ruins. Without documentation, it can be difficult to understand what they were. A rectangular concrete chamber might appear to be an ordinary foundation. A series of ventilation shafts might look like drainage structures. A buried pipeline might be mistaken for an old utility line. A bunker entrance hidden beneath trees might be almost invisible to someone walking nearby. But during the war, these sites were carefully integrated into a security system. Access would have been controlled. Workers might have been screened. Guards monitored entrances. Documents could identify storage capacity, fuel types, and distribution schedules. Railway movements were managed. Camouflage was maintained. Security mattered because petroleum was a strategic resource. The enemy did not need to know every detail about a depot. Even discovering its approximate location could allow aerial reconnaissance to focus on the area. Once a pattern of activity was recognized, the facility might become a bombing target. This created an intelligence war surrounding the fuel system. Allied reconnaissance aircraft photographed German industrial areas and transportation networks. Analysts studied patterns, structures, railway traffic, smoke, construction, and changes in the landscape. What appeared to be an ordinary forest or industrial compound could be examined from above and compared with earlier photographs. Camouflage was therefore a constant battle between concealment and detection. German engineers might cover structures with earth. Buildings could be painted to blend with surrounding terrain. False structures might be constructed. Trees could be planted or preserved around installations. Above-ground equipment could be minimized. But camouflage had limits. A facility that received railway tank cars regularly left clues. A facility with fuel pumps required roads. Workers had to arrive. Vehicles had to depart. Ventilation had to occur. Pipes had to connect to something. A large logistical system inevitably produced signatures. The Allies became increasingly skilled at recognizing those signatures. The destruction of German fuel production in 1944 is one of the most important stories of the final year of the war. Allied bombing campaigns against oil facilities sharply reduced Germany's ability to produce and distribute petroleum products. The attacks did not instantly eliminate every drop of fuel, but they disrupted the system on which the armed forces depended. The effects accumulated. Factories struggled to operate. Transportation slowed. Air units faced shortages. Army formations received less fuel. Training was reduced. Maintenance became harder. Every shortage created another shortage. A shortage of fuel meant fewer vehicles could move spare parts. Fewer spare parts meant more vehicles remained broken. More broken vehicles meant greater dependence on rail transport. But damaged railways meant rail transport became less reliable. This was a vicious cycle. Underground storage could preserve fuel, but it could not manufacture more fuel. That distinction is essential. A bunker was a bank account, not a factory. It could protect reserves, but it could not replenish them indefinitely. By late 1944, German planners were therefore confronted with a terrible calculation. How should limited fuel be allocated? Should fighter aircraft receive it? Should armored divisions receive it? Should transport units receive it? Should factories receive it? Should the Navy receive it? Every decision meant something else received less. The German military's different branches competed for fuel because all of them needed it. The Luftwaffe needed aviation gasoline. The Army needed gasoline and diesel. The Navy needed fuel oil and diesel. Industry needed petroleum products for production. Civilian transportation also depended upon fuel. The result was not simply a military shortage but an economic crisis. Germany's synthetic fuel industry had become indispensable, yet it was highly vulnerable to bombing. Coal could be transformed into liquid fuel, but the process required huge industrial complexes, energy, machinery, chemicals, and infrastructure. When those facilities were repeatedly attacked, production became increasingly difficult. The underground storage bunkers were therefore the final protected layer of a system whose upstream components were collapsing. Some facilities may have been filled only partially by the end. Others may have held reserves that could no longer be distributed. Still others may have been emptied before advancing forces arrived. The exact story varied from site to site. There was no single German bunker design or single storage system. Germany occupied a large territory, and fuel facilities were constructed under different organizations and at different times. Some belonged directly to military supply networks. Others were associated with industrial companies or state organizations. This diversity is important because popular descriptions of German fuel bunkers can make the system sound more uniform than it really was. In reality, the network was fragmented. There were large strategic depots, smaller regional storage points, airfield fuel systems, industrial storage tanks, railway-connected facilities, and temporary field dumps. Some were heavily fortified. Others relied primarily on concealment. Some were underground. Others used above-ground tanks protected by earth embankments. The basic goal, however, remained the same: keep fuel available and prevent the enemy from destroying it. The underground approach offered several advantages. A buried tank was less visible from the air. Earth and concrete provided protection against fragmentation and blast effects. Temperature changes could be reduced. Storage could be distributed across multiple chambers. Pipelines could be hidden beneath the ground. But underground construction also created serious challenges. Excavation could reveal the facility during construction. Groundwater could enter. Structural failures could occur. Ventilation systems had to work. Maintenance became more difficult. If an accident occurred underground, emergency response could be extremely dangerous. There was also the problem of pumping. Fuel does not simply flow wherever it is needed. It must be transferred through a controlled system. Pumps, valves, pipes, and pressure systems must function. If electrical power fails, backup systems may be required. In the final months of the war, electrical reliability itself became a problem. Bombing disrupted power networks. Coal shortages affected electricity production. Factories were damaged. Personnel became scarce. The entire infrastructure supporting a bunker could fail even if the bunker itself remained intact. This is why hidden fuel facilities should be understood as part of an interconnected system rather than isolated underground rooms. Consider the people who worked inside them. Fuel storage required trained personnel. Workers had to monitor tanks, operate pumps, inspect pipes, maintain equipment, and follow safety procedures. These jobs were dangerous even under normal conditions. During wartime, the risks increased. Air raid alerts could interrupt operations. Power failures could stop pumps. Enemy attacks could damage access roads. Workers might be ordered to continue operating during dangerous conditions. As Germany's manpower situation deteriorated, experienced workers became increasingly valuable. At the same time, the war consumed people. Skilled industrial workers were transferred. Military personnel were mobilized. Factories lost employees. Foreign labor was used extensively throughout the German war economy, including in many industrial sectors. The history of wartime German fuel production and infrastructure is therefore also connected to the broader history of forced and coerced labor. Behind the concrete and steel were human beings working under conditions that could be brutal, especially in sectors connected to the Nazi forced labor system. This human dimension is often forgotten when bunker stories focus only on engineering. The bunkers were not empty machines. People built them. People maintained them. People guarded them. People transported the fuel. People eventually had to decide whether to abandon or destroy them. By 1945, Germany's situation had become desperate enough that the normal distinctions between strategic reserve and immediate emergency supply were collapsing. Every container mattered. Every truckload mattered. Every train mattered. And every surviving bunker represented a potential source of mobility. When Allied armies crossed into Germany from the west, fuel shortages affected German resistance immediately. American forces themselves depended upon enormous logistical systems, and Allied planners understood the value of German fuel infrastructure. Capturing a depot could be almost as valuable as destroying one. If the fuel was usable, it could potentially be repurposed. If the facility was intact, it could provide logistical advantages. Therefore, advancing forces had strong incentives to locate German fuel storage sites. Intelligence units, engineers, local informants, captured documents, aerial photographs, and reconnaissance all contributed to identifying infrastructure. The secrecy surrounding the bunkers could delay discovery, but it could not guarantee permanent protection. Once territory changed hands, hidden infrastructure often became visible. Doors were opened. Maps were found. Pipelines were traced. Storage tanks were inspected. What had once been classified became evidence. In the aftermath of the war, Allied investigators also examined German petroleum infrastructure to understand how the German war economy had functioned and why the bombing campaign had been effective. The surviving facilities became physical evidence of industrial warfare. They demonstrated the scale of German attempts to protect fuel. They also demonstrated the limits of those efforts. A bunker could withstand bombs, but Germany could not build enough underground storage to solve a production crisis. A hidden depot could conceal fuel, but it could not conceal the railway network required to distribute it. Concrete could protect tanks, but it could not stop enemy aircraft from destroying the factories that produced the fuel in the first place. The deeper lesson was strategic. Modern warfare depends upon systems. Destroying one component may not be enough. But attacking enough connected components can cause the entire system to fail. The Allied campaign against German oil production is an example of this principle. The objective was not simply to eliminate storage tanks. It was to reduce the enemy's ability to make, transport, store, and use fuel. Once that system began failing, Germany's military capabilities deteriorated rapidly. The famous German armored formations of the early war had been built around mobility. Blitzkrieg depended upon rapidly moving tanks, trucks, artillery, engineers, and supply columns. Fuel was therefore central to the operational concept. In 1940, German forces demonstrated how mobility could overwhelm opponents. By 1944 and 1945, the same military increasingly suffered because mobility had become impossible. The contrast could hardly have been more dramatic. At the beginning of the war, German forces sometimes advanced so quickly that supply units struggled to keep up. At the end, supply units often had fuel but could not move, or vehicles could move but had no fuel. The strategic balance had changed completely. One of the most revealing examples of fuel scarcity came during Germany's final major Western offensive, the Ardennes Offensive of December 1944. German planners knew that fuel was a critical constraint. The offensive required armored and mechanized units to advance rapidly through difficult terrain. Capturing Allied fuel stocks was therefore an important part of the plan. German units were instructed to seize fuel wherever possible. This shows just how severe the shortage had become. An army planning an offensive was partly depending upon capturing the enemy's fuel to continue its advance. The gamble failed. The offensive eventually stalled, and fuel shortages contributed to the inability of German formations to maintain momentum. The lesson was clear: fuel could determine the distance an army could travel. A strategic plan could exist on paper, but the physical limit was often measured in liters. This makes the hidden bunkers of Germany's final months particularly fascinating. They represent the physical manifestation of a strategic paradox. Germany still possessed sophisticated engineering capabilities. It still had underground facilities. It still had storage systems. It still had trained personnel. It still possessed advanced aircraft, tanks, submarines, and industrial machinery. But it lacked the resources required to operate them at the necessary scale. Technology could not compensate for logistics. And logistics could not compensate for strategic isolation. By early 1945, the remaining fuel reserves were being consumed by a military fighting on multiple fronts. The Soviet offensive from the east placed enormous pressure on German forces. The Western Allies advanced from the west. Bombing continued. Transportation networks deteriorated. Industrial production was disrupted. Cities were devastated. The German state was losing its ability to coordinate resources. Under these conditions, hidden fuel depots became isolated pockets of strategic value. Some were emptied. Some were destroyed. Some were captured. Some remained undiscovered for years. The idea that significant quantities of wartime material could remain hidden underground after the war is not surprising. Underground facilities are difficult to inspect completely, especially when entrances are sealed or destroyed. In some locations, fuel contamination may have created long-term environmental problems. Petroleum can penetrate soil and groundwater, and abandoned storage tanks can corrode. Remediation can become expensive and technically complicated. This creates another legacy of wartime fuel bunkers. Their history did not necessarily end in 1945. Some sites continued to affect the landscape decades later. In forests, traces of military construction could remain beneath vegetation. In industrial areas, old tanks and pipes could survive beneath newer buildings. Railway alignments could reveal the former existence of depots. Concrete structures could remain as silent reminders. Modern environmental investigations have sometimes revealed the presence of old petroleum contamination at former military and industrial sites. The physical landscape therefore preserves fragments of the fuel war. But perhaps the most striking thing about these bunkers is how ordinary they can appear. A visitor expecting an enormous underground fortress might instead find a concrete doorway, a ventilation shaft, or a low mound covered in grass. The true scale is often underground. That is the point. A successful bunker was supposed to disappear. Its greatest achievement was not to look impressive. It was to remain unnoticed. The men who designed these facilities understood that the strongest defense might be invisibility. But invisibility was difficult in an era of aerial reconnaissance. The Second World War saw enormous advances in photography, intelligence analysis, radar, and reconnaissance aircraft. The sky became a battlefield of information. Factories, railway yards, bridges, oil facilities, and military depots could be photographed from thousands of meters above. Analysts compared images over time. New construction became visible. Camouflage was evaluated. Bomb damage was assessed. Transportation patterns were studied. This meant German fuel infrastructure was under constant observation. The bunkers could hide tanks, but they could not always hide the activity surrounding them. A railway siding with repeated fuel deliveries was suspicious. A road carrying tanker trucks into a forest was suspicious. A factory suddenly receiving unusual quantities of coal or chemicals could attract attention. An airfield consuming large quantities of fuel could reveal its supporting depots. The entire petroleum system left traces. The Allies exploited these traces. Once oil became a major bombing priority, German attempts to disperse and hide production and storage became increasingly urgent. Fuel facilities were moved underground where possible. Storage was dispersed. Production was decentralized. But decentralization also created new logistical burdens. Instead of maintaining a small number of large facilities, Germany needed more transportation between scattered sites. More transportation meant more vulnerability. This is another recurring principle of logistics. Dispersal can protect assets from a single attack, but it increases the complexity of the network. Germany was trying to make its fuel system resilient while its transportation system was being destroyed. The result was a race it could not win. As the war entered its final months, the remaining fuel had to be prioritized. Fighter aircraft were especially affected. The Luftwaffe had capable aircraft and increasingly desperate defensive missions, but aviation fuel shortages restricted operations. Some pilots had limited training because fuel could not be wasted. Aircraft could be repaired and still remain grounded. The situation was particularly tragic for young pilots. Training hours were reduced while the combat environment became more dangerous. The result was a force that possessed sophisticated machines but increasingly inexperienced personnel. Again, the problem traced back to fuel. Fuel scarcity did not merely reduce the number of flights. It affected the quality of the people operating the aircraft. On the ground, armored units faced similar problems. A tank formation might have dozens or hundreds of vehicles, but only some could be operational. Fuel shortages could force commanders to abandon vehicles rather than risk them being captured. During retreats, German units sometimes destroyed equipment they could not transport. This created enormous quantities of abandoned military hardware across Germany. The image of abandoned tanks and trucks is therefore directly connected to the invisible fuel crisis. What appears to be a mechanical defeat may actually be a logistical defeat. A vehicle can be mechanically perfect and still useless without fuel. This is why military historians often describe logistics as the foundation of warfare. The glamorous image of war focuses on weapons. The practical reality focuses on supply. Every tank requires fuel. Every aircraft requires fuel. Every truck requires fuel. Every supply train requires fuel or coal. Every factory requires energy. Every soldier depends indirectly upon transportation. The hidden bunkers were therefore part of the foundation. They were storage points in a system designed to keep the machinery of war alive. By 1945, that machinery was starving. The final days of the German war saw enormous quantities of fuel lost, destroyed, abandoned, or captured. Some reserves were deliberately burned. Some were consumed by retreating units. Some were trapped behind advancing Allied forces. Some remained in underground facilities until discovered. For the people occupying the bunkers, the end could arrive suddenly. One day the facility might still be under German control. The next, enemy forces could be nearby. Orders might arrive to evacuate. Or to destroy the installation. Or to continue operating. Or there might be no orders at all. Communications were collapsing. Local commanders increasingly had to make decisions without reliable information. A bunker filled with fuel could become a strategic liability. If captured, it could help the enemy. If destroyed, it could provide fire or explosion risks. If abandoned without destroying the fuel, personnel could be accused of failing to follow orders. The final decisions were therefore often made under extreme pressure. Some sites were destroyed successfully. Others survived. The difference could depend on geography, timing, local command decisions, and the speed of the Allied advance. The surviving bunkers became archaeological time capsules. Inside them could be remnants of the infrastructure that supported Germany's war economy: valves, pipes, pumps, warning signs, electrical systems, storage chambers, drainage channels, and access tunnels. Even when empty, such a facility could reveal how carefully Germany had engineered its fuel network. The concrete itself tells a story. Thick walls indicate expected blast pressures. Door designs reveal security requirements. Ventilation arrangements reveal the dangers of vapor. Pipeline layouts reveal how fuel entered and left. Railway connections reveal how the facility fit into the larger network. Storage capacity reveals the scale of planned operations. A bunker is therefore more than a physical object. It is a map of strategic priorities. The decision to spend enormous resources constructing underground fuel storage demonstrates how highly petroleum was valued. Germany was willing to divert concrete, steel, machinery, labor, and engineering expertise into protecting fuel. That investment tells us something profound. Fuel was not simply one supply item among many. It was a strategic resource capable of determining whether entire armies could function. The irony is that the more Germany invested in protecting fuel, the more obvious the shortage became. A country with abundant petroleum might need little concern about hiding every reserve. A country facing fuel scarcity must protect every remaining supply. By 1945, the German state was in the second situation. The bunkers represented scarcity made physical. They were underground because the resource inside had become too valuable to leave exposed. The darkness of the bunker therefore mirrored the darkness of Germany's strategic situation. But there was another dimension. The bunkers were built for a war Germany expected to control. Many were planned when German forces still held vast territory and possessed operational freedom. They were designed to support an expanding military system. By the time they mattered most, Germany was shrinking. Front lines were approaching. Transportation routes were disappearing. The strategic geography had reversed. A depot once positioned safely behind the front could suddenly be only a short distance from enemy forces. A facility designed to support an offensive could become a target during a retreat. A reserve intended for future operations could become inaccessible. This is one of the cruelest aspects of military infrastructure. Buildings can outlast the strategy that created them. The concrete remains even when the political and military assumptions behind it have collapsed. Today, when people walk through a surviving bunker, they may see empty chambers and rusted equipment. But during the war, those same chambers were part of a vast logistical system. Fuel flowed through them. Orders were issued around them. Workers monitored them. Vehicles waited outside. Trains arrived. Military units depended upon them. And somewhere far away, aircraft and tanks consumed the fuel that passed through their pipes. The bunkers connected the industrial heart of Germany to the battlefield. Their importance can be understood by imagining what happened when the connection broke. If a refinery was destroyed, fuel production fell. If a railway was destroyed, fuel could not move. If a depot was bombed, reserves disappeared. If a truck was destroyed, the last stage of delivery failed. If an airfield lacked fuel, aircraft remained grounded. If an armored division lacked fuel, tanks stopped. The chain was continuous. Break one link and the consequences spread. This is why Allied planners increasingly focused on petroleum. They understood that destroying fuel could reduce German military power without having to destroy every tank, aircraft, and truck individually. A fighter sitting on the ground because it has no gasoline is already neutralized. A tank parked because its fuel tanks are empty is already defeated in one crucial sense. A transport fleet without fuel is incapable of supplying the front. Strategic bombing therefore attacked the system rather than merely the weapons. The hidden bunkers were the system's attempt to survive. And for a time, they did. They protected reserves. They allowed fuel to be distributed despite bombing. They gave German forces pockets of logistical resilience. But by the final months, the scale of destruction had become too great. The bunkers could preserve what existed. They could not replace what was being lost. The last German fuel was therefore consumed in a war machine already running down. Some went into aircraft that flew their final missions. Some went into tanks that made their final movements. Some went into trucks carrying the last ammunition supplies. Some powered generators and industrial equipment. Some was burned during retreat. Some was captured. Some remained underground. The phrase, last fuel, therefore does not refer to one particular bunker or one final tank. It represents the broader phenomenon of Germany's dwindling petroleum reserves during the final phase of the war. Behind each surviving storage facility lies a different story. One might have been emptied days before liberation. Another might have been partially destroyed. Another might have been captured intact. Another might have remained sealed for decades. The physical evidence varies, but the strategic story is remarkably consistent. Fuel became scarce. Protection became more important. Storage moved underground. Transportation became increasingly vulnerable. Production collapsed. And eventually the war ended. When the guns finally fell silent in May 1945, the underground fuel infrastructure remained scattered across the defeated Reich. Some facilities were examined by Allied engineers. Some were dismantled. Some were repurposed. Others were sealed. Over time, forests grew over entrances. Industrial sites changed ownership. Roads were rebuilt. Railways were rerouted. New buildings appeared. The landscape forgot what had been beneath it. But concrete remembers. A bunker wall does not explain itself. It simply remains. The story must be reconstructed from plans, photographs, documents, surviving structures, and historical context. And when that reconstruction is made, the importance of these hidden places becomes clear. They were not secret vaults filled with treasure. Their contents were far more mundane and far more consequential. Petroleum. A liquid that could determine whether an army moved or stopped. The entire German war effort depended on it. The tanks that became symbols of German military power required it. The aircraft that dominated the skies in earlier years required it. The trucks that carried ammunition and food required it. The trains and industrial machinery supporting the war economy depended on energy. Without fuel, the machinery of modern war became stationary. This is why the hidden bunkers deserve attention. They reveal the invisible side of the conflict. Wars are often remembered through battles, generals, weapons, and dramatic moments. But behind every battle is a supply system. Behind every armored advance is a line of fuel trucks. Behind every air mission is a fuel storage facility. Behind every military operation is an enormous logistical infrastructure. The bunkers were where part of that infrastructure became physical and tangible. They were the reservoirs of mobility. And when those reservoirs ran dry, Germany's ability to wage war collapsed with them. The final irony is that many of these structures were built to survive destruction. Their walls were designed to resist bombs. Their locations were concealed. Their fuel was protected underground. Yet the war ultimately defeated them without needing to destroy every bunker. The larger system simply became unsustainable. A fortress can protect a resource. It cannot create the resource. A bunker can hide fuel. It cannot make an enemy's bombers disappear. It cannot repair a destroyed railway. It cannot reopen a refinery. It cannot replace trained pilots. It cannot stop an advancing army. It cannot reverse a strategic defeat. By 1945, the hidden fuel bunkers had become monuments to that reality. They represented the extraordinary engineering effort Germany invested in preserving its petroleum reserves, but they also represented the limits of engineering when confronted by overwhelming industrial and logistical pressure. Walking into one today, the first sensation might be silence. The pumps are gone or rusting. The tanks are empty. The lights no longer operate. The pipes carry nothing. The railway tracks may have disappeared. There are no tanker trucks waiting outside. There are no mechanics, guards, engineers, or drivers. Only concrete remains. But beneath that silence is the memory of movement. Fuel once traveled through these tunnels. Orders once determined where it would go. Vehicles once depended upon it. And soldiers somewhere on distant fronts waited for deliveries that might determine whether they advanced or retreated. The bunker was never the battlefield. But the battlefield depended upon the bunker. That is what makes these hidden sites so important. They tell the story of a war that was fought not only with weapons, but with energy. They show how industrial power could sustain armies across continents. They reveal why petroleum became a strategic target. And they demonstrate how quickly military power can collapse when its energy foundation disappears. Germany entered the war with a formidable military machine. It conquered territory with speed. It developed advanced aircraft, tanks, submarines, and vehicles. But the machine consumed fuel at an enormous rate. The longer the war continued, the harder it became to replace what was consumed. Allied bombing intensified. Production declined. Transportation networks were damaged. Front lines moved closer. The remaining reserves were increasingly hidden, dispersed, guarded, and rationed. The bunkers became darker, quieter, and more important. Then, eventually, they became irrelevant. The war ended. The fuel crisis was no longer a question of how much Germany could preserve. Germany no longer controlled the future of the system. The surviving fuel belonged to the victors, the occupation authorities, or the landscape itself. Some of it was recovered. Some was destroyed. Some disappeared through leakage or contamination. Some remained forgotten. But the history remained underground. In a sense, these bunkers are the opposite of monuments. Monuments are built to be seen. Bunkers were built not to be seen. Monuments announce their importance. Bunkers conceal theirs. And yet the hidden structures may tell us just as much about the war as the famous memorials. They show what governments feared losing. They show where resources were concentrated. They reveal the infrastructure behind military power. They expose the enormous effort required to keep an industrial war machine alive. Most importantly, they remind us that military power is never only about weapons. It is about fuel, transportation, factories, maintenance, food, electricity, communications, and human labor. Remove enough of those foundations, and even the most heavily armed force can become immobile. That was the fate Germany faced in the final months of the Second World War. Its last fuel reserves were not simply disappearing from tanks. They were disappearing from an entire system. The refineries struggled. The synthetic fuel plants were attacked. The railways were damaged. The trucks were immobilized. The aircraft were grounded. The tanks stopped. And beneath the earth, hidden behind concrete walls, the remaining reserves waited. Some were used. Some were destroyed. Some were captured. Some were forgotten. But none could change the final outcome. The bunkers had protected Germany's last fuel from bombs. They could not protect it from history. And that may be the most powerful lesson left behind by these hidden underground facilities. The war machine does not live inside the bunker. The bunker only stores what the machine needs. When the larger system fails, even the strongest underground vault becomes nothing more than an empty chamber beneath the earth. Today, the surviving remnants of Germany's wartime fuel infrastructure offer a rare glimpse into that invisible war. They remind us that every dramatic battle had a quieter struggle behind it, the struggle to move resources from factories to railways, from railways to depots, from depots to vehicles, and from vehicles to the front. At the end of that chain was often a single question. Was there enough fuel? In the final months of Nazi Germany, the answer was increasingly no. And that simple shortage helped determine the fate of armies, aircraft, tanks, factories, and ultimately the regime itself. Deep beneath the forests and industrial landscapes, Germany had tried to hide the liquid that powered its war. It had built concrete chambers. It had buried tanks. It had concealed pipelines. It had dispersed storage. It had guarded entrances. It had developed elaborate systems to keep the resource safe. But the world above the bunkers was changing too quickly. The Allied armies advanced. The Soviet armies advanced. The skies belonged increasingly to the Allies. The industrial system was collapsing. The railways were breaking. The fuel plants were burning. The reserves were disappearing. And eventually, there was nowhere left to retreat. The hidden bunkers could delay the inevitable, but they could not prevent it. That is why the story of Germany's last fuel is not ultimately a story about secret underground rooms. It is a story about the limits of power. A nation can build enormous armies. It can design sophisticated weapons. It can construct underground fortresses. It can hide its resources beneath meters of earth and concrete. But none of those things can guarantee victory when the industrial and logistical foundation beneath them is collapsing. The bunkers survived because they were designed to survive. The war machine did not. And when the last fuel finally disappeared into aircraft engines, tank engines, truck engines, generators, fires, or abandoned storage tanks, one of the most powerful military systems of the 20th century was reduced to silence. Beneath the ground, the pipes stopped carrying fuel. Above the ground, the engines stopped. The roads emptied. The railways fell quiet. The aircraft remained on damaged airfields. The tanks that had once crossed Europe stood abandoned. And the bunkers, built to preserve Germany's mobility, became silent underground chambers. Their walls remain as evidence of a desperate attempt to protect the last reserves of a collapsing war economy. Their existence tells us something that battlefields alone cannot. Wars are won and lost not only where armies meet, but where resources are produced, transported, stored, protected, and consumed. The hidden fuel bunkers were part of that invisible battlefield. They were warehouses beneath the earth. They were logistical lifelines. They were targets. They were symbols of scarcity. And in the end, they were tombs for a system that had run out of fuel. When we look back at the final months of the Second World War, it is tempting to focus on the dramatic final battles and the collapse of the German front lines. But beneath those events was another collapse, quieter and more fundamental. The collapse of movement. And movement depended upon fuel. That is why the hidden bunkers matter. They allow us to see the war from below. Not from the cockpit of a fighter. Not from the turret of a tank. Not from the command room of a general. but from the underground chambers where the fuel waited before becoming motion. There, in darkness, was the energy that could move an army. And by the spring of 1945, there was simply not enough of it left. The bunkers had done their job. The fuel had been protected. But protection was no longer enough. The war had become larger than the bunkers. And when the final German forces surrendered, the underground reservoirs of petroleum became one more reminder of a devastating industrial conflict in which energy itself had become a weapon. The last fuel could be hidden. It could be guarded. It could be stored beneath concrete. But it could not be multiplied. And once it was gone, the engines stopped. The engines stopped, and the war machine stopped with them.